Hello class, we will again continue with our lecture video on differential calculus. Today we will discuss about differentiation. Now here are the formulas that has been given to you in your notes, and kindly download the DC notes number 4. So here we have the first one, derivative of E constant. Now when you derive a constant, the answer will always be 0. Okay. Now, for derivative of the sum, considering that we have here two terms, u and v, when we derive these two terms here, we will be deriving u and then deriving v. So, simple as that. And that is your derivative of a sum. For derivative of a product, we have there u and v. So when we derive u multiplied with v, first we will copy u and then derive v. Plus, so they are separated with the plus sign, plus we copy v and then we derive u. So that's how we go with the derivative of a product. Now, how about derivative of a quotient? For the derivative of a quotient, u over v. So first, we will be having the denominator v squared here, and then we will copy v or the denominator. So, if you see the pattern, we have there square the denominator, copy the denominator, derive the numerator, and then separate with a minus sign. Okay? Then, you copy the numerator and then derive the denominator. So, it will need some getting used to. Again, we will repeat. You square the denominator here at the denominator part, copy the denominator, derive the numerator, minus, copy the numerator, and then derive the denominator. Now, there's another way to remember how to derive, how to get the derivative of a quotient. Now, we will follow here, or we will say that u here, the numerator is your high, because it's high or above. Then your denominator here is your low, okay, because it is lower. Okay? And we will have here a pattern wherein we use the pattern low, derivative of high, minus high, derivative of low, all over low. Okay? So, low di high, minus high di low, over low. Okay? So, it's the same pattern. The low here is the denominator v. The derivative of high is the derivative of the numerator, minus the high is the numerator u. Then we have the derivative of low, and that is the derivative of the denominator. And then low here is just the square of the denominator. Okay? Or low, the square of the lower part. So, there goes your low di high di low, over low. Now, how about number 5? Derivative of a product of constant and variable. It is a special case. So, here, this pattern actually is the same with the derivative of a product. So, here, it's the same with derivative of a product. If we try to get the pattern of derivative of a product, we will copy C, then derivative of V, plus we copy V, and then we have the derivative of the constant here. Now, what happens when we derive the constant? Remember, number 1, the derivative of a constant is 0. That is the reason why in this formula, this portion here is not written because it is automatic 0. Because derivative of C over dx is already 0. Okay? So, that's why it's not written here. Okay, for number 6. It is again another special case. Now, to understand number 6 here, we will first study what is formula number 7. So, this is the general power formula. For the general power formula, you have there a term u raised to the power of n. So, u here could either be x or as complicated as x squared plus 2. That could be the u. Okay, so what happens? How do you derive such a pattern? Now, to derive this, we have the 4th step. For the derivative of u raised to n, here, for the derivative of u raised to n, you copy the base u. So, take notice of this part. Copy the base u there. Then, you copy the exponent. The exponent here is n. Then, you copied here the exponent. You bring down the exponent. Then, the exponent minus 1. And then, the derivative of the base. Okay? So, that is the 4th step. The first step is for the derivative. So, for example, we are deriving here derivative of u raised to the power of n. We are going to have the answer of copy u, bring down n. So, step 1 is copy u, the base u. Bring down the exponent n, minus 1 your exponent. Okay, so I forgot to mention the steps. The step 1, copy u, the base. Step 2, bring down the exponent. Step 3, minus 1 the exponent. Then step 4, derive the base. Okay, so that is the 4-step process. So that's how we come up with the pattern here. Right? Now let's go to your formula 6. For the formula 6, we have here, the base here is not u, but rather the base is x. So let's follow the pattern of formula 7. So, for the derivative of x raised to n, so we have there, you copy the base x, bring down the exponent n, minus 1 the exponent, and then what happens? The derivative of the base, dx over dx. So, what happens with dx over dx? That becomes 1. That's the reason why in this formula, dx over dx wasn't mentioned because it's automatically 1. That is a special case. So there's actually no need to remember 5 and 6 formula as long as you know the formulas 7 and number 3. Okay? Now, next one is formula number 8. Formula number 8 is a derivative of a product, but there are 3 different terms. So U, V, and W. So U, V, and W here, how do we derive? So again, if you are deriving product, it is always separated with plus. If you are deriving quotient, it is separated with minus. Okay? So first, we need to take or copy the left side portion, UV. So we have there copy UV, and then derive the rightmost portion, W. So we have there, okay, so we have there UV, copy UV, derive W. What's next? The other ones, so we have there V and W. You copy V and W, derive U, and then you copy U and W, derive V. The point there is, you were able to derive the three letters mentioned here. So we have there W, U, and V. And then you just put the others here in the leftmost portion. So there's no problem whether we are deriving 3 here or we are deriving 4. So the same step happens. So U, V, W, X, even Y or Z. So the same step happens. As long as you are deriving all of them, so still good. Okay. Next, for number 9 formula, we have their derivative of the constant over V. So again, C is constant. So what happens? Remember low di high and high di low. So this is your high, then this is your low. So our pattern a while ago is low di high, high di low. So the low here is, we have there V. So low is V. Low, low, V squared. Low di high, V. Derivative of C. So we have the derivative of C. V, and then derivative of C over V, dV. Derivative of dx, I should say, minus, you copy the numerator, the high, derivative of low. Okay, so what happens here is that derivative of a constant is what? That is 0. So derivative of a constant is 0. So multiplied with V here, it becomes 0. So what's left is negative C, derivative of V over dx, derivative of V over dx over V squared. So this is similar with this one. Okay. Now for the last formula, we have a square root or radical sign. We have their derivative of the square root of U. So what is the pattern to remember in formula number 10? The pattern here is, you in the denominator, you copy the one with the radical sign, put 2 here, so we have the 2 square root of U, and then whatever is inside of the radical sign will be derived on the numerator. Okay, so that is the pattern that we need to get used to. So how do we get used to the patterns presented here? So to remember them, we need to practice solving problems using these patterns. So in your notes, DC notes number 4 in your handout, I was able to give 10 examples for this lesson. We'll solve them one by one. Okay. So for number 1, so the instruction there is differentiate the following. Okay, so let's differentiate number 1, y is equal to 3x raised to negative 1 minus 4x raised to negative 2. So which pattern here applies, or this example applies? So which pattern? We are going to use here the derivative of a sum and the derivative of the powers. Okay, the power formula. So let's apply them. So we have here dy, so we have here dy over dx for derivative. So we are deriving already. Equals, so as you have remembered, we have there the power, the 4 steps, the power. So you have there, we copy the constant, we bring down the exponent, we copy the base, then the exponent is minus 1. So if we follow this step-by-step process, copy the base, x, then bring down the exponent, negative 1, then we have there the constant. Or you can also have here, copy the base as 3x, then you have there the constant 3, then negative 1 for the exponent, then we have negative 1 minus 1. Then what is the derivative of, sorry about that. So the base here actually is x, sorry. So x. Then you just leave out the constant there. Bring down negative 1. Negative 1 minus 1. Derivative of x is 1. So derivative of x is 1. So we have there the 4-step process. Minus, put here the constant. Copy the base. Bring down the exponent. The exponent minus 1. And then derive the base, which is the x. Okay. Then let's simplify. This becomes negative 3 x raised to negative 2 plus, you have there 8 x raised to negative 3. So that is your answer. Or we can have an answer like this form. If you don't like seeing the negative sign for the exponent. Or you can have the answer negative 3 over x squared plus 8 over x raised to negative 3. Why is it that it's only the x that's been brought down? So the reason is it is the exponent, it is the x which has the exponent, not 8. If we have put this as parenthesis like this, then the answer will become 1 over 8x raised to 3, because 8 is included as raised to the power of negative 3. But since in our example, the one that has the exponent of negative is only x, so it's only the x which we are bringing into the denominator, so that the exponent becomes positive. So that is the final answer. So we have there 2 possible answers. Okay. two answers. Before number 2, we have there W equals 2/3 minus y squared over 5 plus 4 y raised to 3 over 3. So you're seeing here fraction. So you might have in your mind using the quotient, derivative of a quotient. Can we use derivative of a quotient here? Number 4. Let's see. Yes, we can, but that will be a lot more complicated. What's more simpler is that you look at the denominator part, it is constant. So they are constant. So what do? We can have it like this. 2/3 minus 1/5 of y squared plus 4/3 y raised to 3. Okay, so it is a lot simpler than using the derivative of a quotient. So when we derive derivative of w over derivative of y, derivative of constant here is 0 minus, so we copy the constant 1/5, copy the base y, bring down the exponent 2 minus 1 the exponent, and then the derivative of y is 1. So why are we using dy anyway? For those who might be asking, why dw over dy? We have been using dy over dx. Why is that? So if you notice, there's only 2 letters here. We have their w and y. So since we are deriving here explicitly, so we have there dw over dy. So there's no x here. Okay, so we have there plus 4/3, copy the base y, bring down the exponent 3, minus 1 the exponent, derivative of the base dy over dy, that is 1. Then we have there negative 2/5 y raised to 1. Then we have plus, cancel 3, so we have therefore y squared. Okay, so that is the final answer. Or if you're not satisfied with that, you can have the answer negative 2y over 5 plus 4y squared. So I could still accept that. Next, for number 3. So we will be proceeding for example number 3. So we are looking at a radical sign. So that will cause some to panic. But if we remember the pattern, as long as we can recall the pattern, then we are good to solve this one. The pattern to be used is formula number 10, wherein for a derivative of square root of u, we copy u on the denominator, put here 2, then derive whatever is inside the radical sign. So let's have the pattern written. Okay. So the pattern there is for a derivative, so d dx. So it's not d dx. The derivative of t. Okay. For the pattern a while ago, let's just rewrite it. Okay, so you have there u. Then we have the pattern 2 square root of u, then derivative of u over dx. So that is the pattern. Now, to solve this problem, we have here dx over dt. Okay, so looking at the pattern here, what's in the denominator? We have 2. Then you copy what is the radical sign and inside the radical sign. And then what is the derivative inside the radical sign? We have there dt over dt, right? So take note, we are using dt. So dt over dt, that is immediately equal to 1. Minus, now here comes a lot more complicated part. Here. It is a radical sign and it is in quotient. So we will be using the pattern for the derivative of a quotient. So if you recall, we have the low d high, high d low pattern. Low low. Okay. So let's have the pattern for the derivative of a quotient. So d dx, I might need some space here. So derivative of a quotient, we have there u and then v equals, so low d high, low derivative of high du dx minus high derivative of low dv dx, and then low low v squared. So that is the pattern. Oops. Now let's use that pattern to solve this problem. Okay, let's have some space here. Alright. Okay, so we have there, let's separate it with a line. Okay, so low d high, the low here is square root of t, right? So this is your low and this is your high. So for the low, it is square root of t. Derivative of high, derivative of 1 or derivative of a constant is 0. Minus high, your high here is 1. Then derivative of low, derivative of square root of t is what? You copy square root of t multiplied with 2. Then derivative of t is 1. Then lolo. Lolo here is square root of t squared. Okay? Then let's simplify. So this is already cancelled. Cancel to 0. So we have there 1 over 2 square root of t minus, we have there 0 minus 1 over 2 square root of t over, now what is square root of t square root of t squared? So we will be cancelling the square root sign. Square root of t becomes only 2. Next, so this is 1 over 2 square root of t minus, so what happens here is this portion here, this is actually the numerator, to simplify this, we have the numerator 2, the numerator is 1 over 2 square root of t multiplied with the reciprocal of the denominator. What is the reciprocal of denominator t? Reciprocal of denominator t is 1 over t. Now if we multiply that part there, it becomes, so the answer will go there. Or should I show the answer already? So the answer here is negative 1 over 2t square root of t. Okay, so going back, we have there negative 1 over 2t square root of t. Then this becomes 1 over 2 square root of t plus 1 over 2t square root of t. Then the common denominator for this, for their common denominator they have 2. Then for the denominator we have 2t square root of t. And then for this portion to have t on the denominator, we multiply it with t over t. So if that happens, it becomes t, right? Plus 1. So again, the reason why we were able to have this denominator here is that we multiplied t over t for the first term. Okay, so the final answer here is t plus 1 over 2t square root of t. Okay, so that is the final answer. It's a bit tedious, if you could say. Yeah, especially in this portion here. Sometimes we forget that this is the pattern to be used. If we forget that it is a derivative of a quotient, we might as well go with differentiating only this one. That's a pattern, or that's a mistake that I often observe. Now, what is the other way? You could actually have another way of solving number 3. So what is the other way of solving number 3? What do you think? So we have other solution for number 3. So remember that it is x is equal to square root of t plus 1 over square root of t. What if you're someone like me who's not a fan of the derivative of a quotient and the radical sign? So I just have to remove the radical sign. How do you remove the radical sign and the quotient part? We just transform this into exponent. So square root of t is actually t raised to 1/2 plus 1 over t raised to 1/2. Well, yeah, we were able to remove the square root sign, but now the quotient is still there. How do we remove the quotient part? To remove the quotient part, well, so this is t raised to 1/2. For this part, it's just simply t raised to negative 1/2. Right? Still the same. So we just converted the exponent into negative. Now we will be able to derive this using the derivative of exponents. Okay, so derivative of x over dt is equal to, bring down the exponent, you have there t raised to 1/2, so minus 1 for the exponent. Derivative of t is automatically 1, so I will not put it there, plus, so the exponent negative 1/2 has a negative sign, so I will be putting here a parenthesis. Then t raised to negative 1/2 minus 1. Then we have here 1/2. What is 1/2 minus 1? That is 1/2 minus 2 over 2, right? So the answer here is negative 1/2. Plus, oh no, are we going to plus this one? Okay, so that becomes negative. Negative t, 1/2 t raised to, what is negative 1/2 minus 1? So that is negative 1/2 minus 2 over 2. So that is negative 3/2. Okay, then we now have here so the given is negative, minus. So sorry about that. The given here is a minus sign. Oh, okay. So we have there minus, minus, and minus. Okay, then it becomes plus here, because negative times negative is positive. Okay, so what happens here is this the same with the first one? Not yet. For this one, for the negative exponent to become positive, we will have it in the denominator. 2t raised to 1/2 plus 1 over 2t raised to 3/2. Next, this is 1 over, now 1/2, t raised to 1/2 is automatically square root of t. Plus, how about this one? Now remember that for these 3/2 to become 3/2, that is actually 1/2 plus 1. We have there 2 times t raised to 1/2 times t, right? Because t is raised to 1. Okay. So 1 over 2 square root of t plus 1 over 2t square root of t. Okay, then continue this here. That's equal to, we have there 2t square root of t. Then for this portion here, we have there t. Why? Because for this 2, we have there t over t. We multiply that with t over t. So that's why we have there t plus 1. Okay, so the final answer is t plus 1 over 2t square root of t. So it is same with the answer for the first one. Right, so whatever solution you use for example number 3 or something like this, whatever you wanted to use, whatever is easier for you, using the quotient, the derivative of the quotient, or using the derivative of the general power formula. So when you arrive at the same answer, it's good. Okay. If ever you have questions for this, kindly message me on the MS Teams. So let's proceed for example number 4. In this kind of problem, what do you think is the pattern to be used? For this problem, we will be using derivative of the product. Okay. For the derivative of a product, we have their derivative of u times b equals copy u derivative of b plus copy b derivative of u. So that is the pattern, right? So let's use that pattern. So here, you have u here as b squared plus 3, and then you have b as b squared minus b plus 1. So that is our pattern. So dy, the answer here is, or the solution here is dy over dx. No, we will be using b. So dy over db is equal to, again, copy u here. Oh, sorry, literal u. So copy u, b squared plus 3, then derive b. We will be using a bracket for the derivation. So derive b. So that is 2b, 2 minus 1, minus derivative of b, db over db is 1. Derivative of a constant 1, that is 0. Okay, then we're done with the first part. Second part, plus copy b, the b portion here, b, square, forgot the parenthesis. So we have b squared minus b plus 1, derivative of u, 2b, 2 minus 1, derivative of b is 1, plus derivative of 3 is 0. Okay, then simplify. B squared plus 3 times 2b minus 1 plus b squared minus b plus 1 times 2b plus 0. Okay, distribute. So b squared times 2b, 2b raised to 3, b squared times negative 1, so negative b squared, plus 3 times 2b, that is 6b, then 3 times negative 1, that is negative 3, plus 2b cubed minus 2b squared plus 2b. Then, combine like terms, we have there 4b cubed minus, we have there 3b squared. Then we have 6b plus 2. Okay, so we have 2 then. 8b minus 3. And that is the final answer. So that is the derivative of a product. Let's go for example number 5. For example number 5, we have there f of x equals x squared plus 1 over x squared minus 1. So again, this is derivative of a quotient. So we have derivative of a quotient. So again, for the derivative of a quotient, the pattern here is d dx times ub equals low derivative of high minus high derivative of low, then low b squared. Okay, so let's use that pattern. We have here, for derivative of f of x, we can use prime. Okay, then that is equal to the derivative, b first, b or the low derivative of high, so bracket 2x 2 minus 1 plus 0 minus high, copy high, derivative of low, high d low, 2x 2 minus 1 minus 0, then low square of the denominator. Okay, then simplify. X squared minus 1, we have here 2x minus x squared plus 1, we have there 2x over x squared minus 1 squared. Okay, then expand, distribute, so we have there 2x cubed minus 2x minus 2x cubed minus 2x over x squared minus 1 squared. Then we have there, cancel this one. Negative 2x cubed and positive 2x cubed, 0. So we have there negative 4x over x squared minus 1 squared. Okay, so that is the final answer. Alright. So that is for example number 5. Now, if you would like to try, you can try solving this by another method, since we have running out of time. So we can solve this other method here. We can use this form. F of x is equal to x squared plus 1, then x squared plus 1 raised to negative 1. Maybe you might want to try it and see if you could arrive at the same answer, negative 4x over x squared minus 1. Okay. For number 6, we have there x is equal to square root of m squared plus 5. So the pattern here is for the number 10, the one with the radical sign. So we have there d over dx, square root of u is equal to 2 square root of u for the denominator, and then for the numerator we have the derivative of whatever is inside that radical sign. So that is the pattern. Let's use that in this example. So we have there dx over dm, that is equal to the denominator. Let's just copy it, then put 2 on it. Okay. Then what is the derivative of the numerator? The derivative of the one inside the radical sign. So we have there 2m, 2 minus 1 plus derivative of 5 is 0. So simplify 2m over 2 square root of m squared plus 5. Cancel 2. So the final answer here is m over square root of m squared plus 5. Okay. Simple radical sign. How about for number 7? Okay, for number 7, we have there using the power formula. For the power formula, we have there d dx, derivative of u raised to n, so that is copy u, bring down n, minus 1 the exponent, then derivative of the base. Okay. So let's use that. So the u here, the u in this example is this, the base. The u here is 7x raised to 3 plus 2. That is the u. Okay. So dy over dx equals, so let's copy the base. Copy the base 7x raised to 3 plus 2. Bring down the exponent, 5. Minus 1 the exponent, 5 minus 1. Then derive the base, whatever is inside the parenthesis. So that is 7, bring down 3, x, 3 minus 1, plus derivative of the constant 2, that is 0. Okay, so that is equal to 5. So you cannot multiply this immediately because it has a power here, it has an exponent. As long as there's an exponent here outside the parenthesis, you cannot just multiply whatever is outside. You cannot just distribute it inside the parenthesis. The exponent serves as a lock. As long as the parenthesis has exponent, you cannot distribute any number or variable outside the parenthesis. Okay, so we will copy 5, 7x raised to 3 plus 2 raised to 4. Then we have here 21x squared. Next, simplify further. We have there 5 times 21, 5, 10. 10, 5, 105. X squared. Then we have there 7x raised to 3 plus 2 raised to 4. So that is the final answer. So that is for example number 7.